For years, we've been making videos here on the YouTube platform. And during that time, we have made plenty of how-tos or run tool tests that involve driving fasteners. No matter what type of fastener we use, whether it be Phillips, Torx, or Robertson, it seems to start a great debate down in the comment section. People that use Robertson hail their fastener as the best. Torx users say that there is virtually no cam out, and they use the highest level of engineering in constructing those fasteners. Both tell us that any users of Phillips fasteners must be misinformed, the lowest on the totem pole of users that drive fasteners in any capacity. Well, today, I'm going to tell you, if you aren't using Phillips fasteners, you're missing out on a huge feature that could save your butt on the job site. Welcome back, but if this is your first time here, my name is Vince. Welcome to you especially. The hexabular socket screw drive, often referred to by the original proprietary brand name Torx, or by the alternative generic name Star Drive, uses a star-shaped recess in the fastener with 6 rounded points. It was designed to permit increased torque transfer from the fastener to the bit compared to the other drive systems. The drive was developed in 1967 by Camcar Tektron. Torx is very popular in the automotive and electronics industries because of the resistance to cam out and extend bit life, as well as reduced operator fatigue by minimizing the need to bear down on the drive tool to prevent cam out. So in a nutshell, what they're saying is because of that Torx design, you have less cam out because of better engagement of the drive bit to the fastener itself. That also means that as I'm driving the fastener, there's less of a need to press down on the tool as we're driving that fastener, creating less fatigue of the user during the course of the workday. Moving on to Robertson, which seems to have a very spirited following. It seems that Robertson users are definitely in the mindset that they are far superior to all other fastener users, as well as Robertson fasteners are superior to all other fasteners. Robertson, also known as a square or Scrolox, I will let everybody know that multiple times where I have called Robertson square and interchangeably, people have gone absolutely berserk down in the comments section. And guess what? Make sure you go absolutely berserk down in the comments section below with your thoughts. Robertson is specified as ANSI Type 3 square center and has a square-shaped socket in the screw head and a square protrusion on the tool. Both the tool and the socket have a slight taper, originally to make the manufacture of the screws practical using cold forming and the heads. This taper provides 2 other advantages which have served to popularize the drive. It makes inserting the tool easier and tends to help keep the screw on the tool tip without the user needing to hold it there. Robertson screws are commonplace in Canadairs, though they have been used elsewhere and have become much more common in other countries. As patents expired and the awareness of their advantages spread, Robertson fasteners have become popular in woodworking and in general construction. Combination Robertson Phillips drives are often used in the electrical trade, particularly for device and circuit breaker terminals, as well as clamp connectors. This socket-headed Robertson screw are self-centering, reduce cam out, stop a power tool when set, and can be removed if painted over or old and rusty. It seems as though when being designed, Robertson had a big focus on cam out. They're less likely to cam out. It also, because of the design, had less of a tendency for the fastener to slip off of the tool or the drive. That also meant that less downward force was required to keep the tool from camming out of the fastener when the fastener was being driven. Leave it down below. Which team are you, Robertson or Torx? While you're down there, use the link to get to the merch store. We got the sickest merch in the YouTube tuber industry. Hats, t-shirts, tech shirts, stickers. Now let's move on to the star of this video, the Phillips screw drive, specified as an ANSI Type 1 cross recess and Type H in ISO documentation. It was created by John P. Thompson, who, after failing to interest manufacturers, sold his design to businessman Henry F. Phillips. Phillips is credited with forming Phillips Screw Company, improving the design and promoting the adoption of his product. The original patent expired in 1966, but the Phillips Screw Company continued to develop improved designs. The American Screw Company of Providence, Rhode Island, was responsible for devising a means of efficiently manufacturing the screw and successfully patented and licensed their method. Other screw makers of the 1930s dismissed the Phillips concept because it called for a relatively complex recessed socket shape in the head of the screws, as distinct from the simple milled slot of a slotted type screw. The Phillips screw design was developed as a direct solution to several problems with slotted screws. Increased cam out potential, precise alignment required to avoid slippage and damage to the driver, fastener and adjacent surfaces, and difficulty of driving with powered tools. For some of those that have ever tried to land a power tool onto a slotted fastener and drive it will know. As you try to drive it, there's a high likelihood that it will spin off. The faster you go. It can be done. It requires a great amount of patience and accuracy, and you have a much higher likelihood of slipping off, camming out, and damaging the work area, the fastener, the tool. So what Thompson did was take a single slot and add a second slot the opposite direction, reducing cam out because the bit and tool became self-centering on the fastener. We can land the tool with much more accuracy. It was revolutionary, but that's not the feature we're talking about in this video. Although it did reduce cam out, the design is often criticized for its tendency to cam out at lower torque levels than other crosshead designs and other designs such as Torx and Robertson, per the comment section down below from all of you constantly. Here's the thing. There has been a popular belief that this was a deliberate feature of the design to assemble aluminum aircraft without over tightening the fasteners. So what that means for you on the job site and why you should consider using Phillips in place of Robertson and Torx is, if you were to undersize your pilot hole when fastening into mission critical materials, such as machine fasteners in equipment, what you would experience when driving those fasteners would be cam out. You would have cam out, and it would be deliberate cam out because the goal was to have the tool cam out of the fastener as opposed to having more positive contact with the drive and the fastener or the tool in the fastener and risk snapping the fastener in its hole. If you're having cam out, you need to stop the process you're in and rethink why the fastener is camming out. And that thought process can save you on the job from having a huge disaster. And if you like averting huge disasters by employing engineering that has just blown your mind then smash the like button. It's free for you to do. Doesn't cost you a dime. I mean, literally, you get 7 years of good luck. And all of your fasteners from now on, after smashing the like button, will go in straight and true. With that, I want to say I appreciate each and every one of you for being here. Thanks a lot, everybody. We'll see you all on the next one. Video's over, but I know you want more. So this is how you're going to get it. First thing you need to do is pretend you're this guy. And you're here at the birthplace of freedom. Now ring that bell like it's 1776 and let all notifications through. What? You're not subscribed yet? Well, smash this button here. After that, watch this video here, and maybe over here. See you later.